Now magnetic permeability mu naught is, the magnetic field is mu naught I upon 2r for the circular loop. So this mu naught will be V into R upon I. So magnetic field we have already obtained here, M1 L0 T minus 2 A minus 1 into R. So into R means M1 L1 T minus 2 and divided by ampere. So here will be M1 L1 T minus 2 A minus 2, because it is being divided, so it will come A minus 1 minus 1, so minus 2. Now we can have permeability M1 L1 T minus 2 A minus 2. Now specific heat. So this specific heat is heat per unit mass per unit rise in or change in temperature. So delta T, and Q equals to ms delta T. So here heat is energy M1 L2 T minus 2 divided by M1, and temperature is Kelvin. So here it will be M0 L2 T minus 2 and K minus 1. अब Q equals MC delta T आपने 9 में पढ़ा भी होगा. So S will be equal to Q upon M delta T. So you can get the latent heat also, Q by L. So Q equal to ml. So L will be equal to Q by M only. So that time this Kelvin will be removed there. Now you can get the magnetic or thermal conductivity. You can find thermal conductivity. K is thermal conductivity. The rate of flow of charge, the rate of flow of heat is proportional to area of cross section, inversely proportional to the length, and diagonally proportional to the temperature difference. So this Q by T was Ka delta T by delta L. That means K will be equals to Q into L upon area, time, and Ka T and delta T temperature. So this Q was Ka small t and delta T by delta L, that is L. So you can have here this Q is heat, energy M2 T minus 2 into this L, and this area will get cancelled, divided by 1L, and this time is T and this temperature is K. So here it will be M1 L1. So here it is M1 L1 T minus 2 and minus 1. So T minus 3 and K minus 1. K is QL upon A small t is time and delta T, capital T is temperature here. So M1 L2 T minus 2 divided by L upon A is divided by L only, this time, and this is Kelvin. So here it is M1 L2 divided by L1. So minus 1, that is L1, and this is T minus 1 will come here up. So T minus 3 and K minus 1. Here this K and this is 1. Now you can have magnetic flux. Magnetic flux. This phi equals to B into A. So magnetic field into area. So magnetic field is M1 L0 T minus 2 A minus 1. So here it will be simply M1 L2 T minus 2 A minus 1. See, this is the magnetic field M1 L0 T minus 2 A minus 1. So multiplied by area, so it will become L2. So M1 L2 T minus 2 and A minus 1. Now you can get self-inductance. So phi is Li, or you can say L equals to phi upon I. That means this magnetic flux divided by current. So here it will be M1 L2 T minus 2 A minus 2. Flux divided by current. So flux is M1 L2 T minus 2 and A minus 1 minus A will become minus 2. We can just revise. Viscosity coefficient eta is equal to F upon A upon delta V by delta. That is velocity gradient. So it is the pressure M1 L minus 1 T minus 2 and it is L T minus 1 divided by L. So it will remain T minus 1 only. So here it will become M1 L minus 1 and T minus 2 minus 1 is T minus 1. So here gravitational constant is G. F into R square upon M square. Force is M1 L1 T minus 2 into L2 and M2. So you will get M minus 1. 1 minus 2 is minus 1. L square and L power 1 is L cube and T minus 2. Electric field is force upon charge. So force is M1 L1 T minus 2 divided by charge is A into T. Then you will get M1 L1 T minus 2 and minus 1 becomes minus 3 and A is minus 1. Electric dipole moment is Q into A, that means length. So charge is A and T and L. So it will M0 L1 A1 T minus 1. T plus 1. That means you can write M0 L1. You can write T1 and A1 in sequence this way, so you will get it. Now specific resistance rho is equal to RA by L, that means R into L. So resistance was M1 L2 T minus 3 A minus 1, we have just derived, and divided by A and into length. So that will be equal to M1 L3 and T minus 3 and A minus 2. So magnetic field is force upon I and L length. So it is M1 L1 T minus 2 divided by A and L. So LL will cancel out, say M1 L0 and T minus 2 and A minus 1 is the magnetic field. So electric permittivity of free space, that is Q square upon F into R square, because force was 1 upon 4 pi epsilon Q naught Q1 Q2 upon R square. So here you will have Q square into Q square upon F into R square. So A square T square, force is M1 L1 T minus 2 and R square is L power 2. So here you will get M power minus 1, L power 3 and goes up minus 3, and T is square here and minus 2 then come up, becomes plus 4, and A square is already there. So it will be plus 4. Magnetic dipole moment is M is equal to I into area. So area is simply M0 L square and T0 and A1. And then permeability of free space, that is magnetic field into length divided by current. So magnetic field we have just got it, M0, magnetic field is here M1 L0 T minus 2 A minus 1, and we have to multiply it by only length. So M1 L1 T minus 2 and we have to divide by the current, so minus 2 becomes that way. So here we have specific heat is current per the heat per unit mass per unit change in temperature. Q equals to MC ms delta T. So S is equal to Q by M delta T. So this is heat is the energy or the work M1 L2 T minus 2 divided by M, and here the Kelvin temperature. So it will be M0 L2 T minus 2 and K minus 1. Now you can have thermal conductivity K is Q into L divided by A into T into delta T. L upon A will remain L divided by. So m1 L2 T minus 2, this is the heat divided by L power 1, this is the time T1, and here's the Kelvin K1. So when this L1 comes up, so it will become m1 L1, 2 minus 1 is 1, and T minus 2 minus 1 is T minus 3, and K becomes minus 1. Now we can get magnetic flux phi is equal to B into area. So magnetic field into area, that means m1 L0 into means L square, then L square, T remains minus 2 and A remains minus 1. Say, now self-inductance, phi is equal to L into I, so L is equal to phi upon I. So magnetic flux divided by current. So magnetic flux is m1 L2 T minus 2 and divided by current is minus A and minus A, that is minus 2. Magnetic flux is m1 L2 T minus 2 minus A minus 1. So here it will divided one more current. So it is m1 L2 T minus 2 A minus 1 is A minus 2. So this way how you can derive if you know the formulas. So practice it and you will also remember.